Last time we developed a formula that let us find the vertex of the parabola. Another useful question to ask is when will a quadratic evaluate to 0? And we can derive a similar formula. So let's start with the most generic quadratic and set it equal to 0. In the last video, we did quite a bit of work to complete the square on the left-hand side, and we obtained an expression like this. This is actually most of the work already. All I need to do is isolate x in this expression, and the x appears only in one place. So I might begin by moving the c minus b squared over 4a to the right-hand side. I combine the two terms on the right with a common denominator. I can divide both sides by a, take the square root. Notice that taking the square root here introduced the plus and minus. And finally subtract b over 2a. Here I was lucky and already had a common denominator, so I can go ahead and combine those immediately. So if we read the first and the last line, a general quadratic is equal to 0 whenever x is equal to this expression at the bottom. So what all that work showed is that a general quadratic is equal to 0 at the x values specified by this equation. I say solutions because the inclusion of the plus minus means that x could have 0, 1, or 2 possible values. From a graphical perspective, we might say that the parabola has roots or zeros at these x coordinates. These two pictures show examples that both have 2 roots. Imagine taking the picture on the left and sliding it upward. The parabola would continue to have 2 roots until the vertex was exactly on the x-axis. And then you might say that it only has 1 root, which occurs exactly at the vertex. And if you pushed it any higher than that, then that parabola would have no roots at all, because the vertex is high above the x-axis, and the parabola opens upward, so it will never come back down to the x-axis. We could obtain a similar situation by pushing the graph on the right downward. This is why I say that there could be 0, 1, or 2 roots. So how can we make use of this formula? This function tells me the height of a ball after t seconds. The parabola shows how the ball rises or falls over time. Even though we can plug in negative values of t into this function and get an answer, as the graph shows, it doesn't make sense to do so from the terms of our model. We release the ball at time t equals 0 and then begin measuring, so negative values of t don't have any interpretation in this context. So when will the ball hit the ground? In other words, when will the function that determines height equal 0? This is exactly what our quadratic formula is for. So here I've written down the generic quadratic formula, and for our particular function, a is negative 32 over 400, b is 1, and c is 5. So I substitute in all that information, and then carefully work it out to receive 2 answers. When I use plus from the plus minus, I get an answer of negative 3.83. And when I use the minus from the plus minus, I get an answer of 16.33. For us, the answer of negative 3.83 doesn't have an interpretation. We saw in the picture that there was a root on the left side of the graph, but we're interested in the root that's on the right at 16.33 seconds. We'll discard the meaningless answer and say that the ball hits the ground at approximately 16.33 seconds. Will the ball reach 7 feet? In other words, can the function that determines height be equal to 7? We can't immediately apply the quadratic formula to this equation, because the quadratic formula can only answer when a quadratic is equal to 0. But subtracting 7 from both sides gives me a slightly different quadratic that is equal to 0, and now I can apply the formula. So I begin again with the generic quadratic formula, and this time a is negative 32 over 400, b is 1, and c is negative 2 rather than 5. So I substitute all that information in, and again I come up with 2 solutions, 2.5 and 10. So the answer to this question is yes, the ball reaches 7 feet twice. As it moves upward, it reaches a height of 7 feet after 2.5 seconds, and then after a while it reaches its maximum height and begins to come back down, and after 10 seconds it reaches 7 feet again. Will the ball ever reach 10 feet? We're in essentially the same situation. Will the height function ever equal 10? If I subtract 10 on both sides, now I have a slightly different quadratic that's equal to 0, and I can return to the quadratic formula, and in this case all the values are the same except that c is negative 5. If you type this directly into your calculator, you'll receive an error. If I simplify what's underneath the square root, we can see why. We have negative 0.6 underneath the square root, and square roots of negative numbers are undefined. This is the source of the error. This means that the height function can never equal 10, because that equation has no solutions. So the ball never reaches 10 feet.